learn here. Thanks for that. That's fantastic. Feel free to watch him as he works here as and listen to me. But before I start, I really want to give a big thank you to Zach and Jacob from Packet, who have been huge supporters of the Computing Foundation and the whole cloud native ecosystem. And I'm curious, who here is familiar with the CNCF Community Infrastructure Lab? It's actually provided by Packet, and Ed here works with us on it, where both CNCF projects and random open source developers come to us and say, hey, we're doing this kind of software, we'd like to try and test it at scale. We were hoping we could have some server resources, and working with Packet, we're able to make those available. And so it's really a fantastic example of Packet giving back. They also, of course, build their platform, as everyone does, using a ton of open source software. So we really appreciate that collaboration. Okay, I am from the Cloud Native Computing Foundation. I'm the executive director. We're going to be 3 years old next month, and it's been a crazy 3 years. We are actually now the largest open source software foundation and the fastest growing. We went from 28 members 3 years ago when we started to 340 today. And we started with Kubernetes coming in as the first project. We now have 30 different projects, open source projects in the foundation. You can see our 19 platinum members representing all the public clouds and the biggest enterprise software companies. And this chart is a way that we think about the different levels of our projects. We just announced the third project to graduate today is called Envoy. That came with Kubernetes and Prometheus, and it is suitable for the early majority. So we described 2018 as really being the year that Kubernetes crossed the chasm. These other projects have come with it. We then have another 17 incubating projects that are suitable for early adopters, and then these 11 sandbox projects that are more suitable for innovators or techies. And we're part of CNCF's role is to provide that communications and the messaging around how enterprises can think about different projects and when they might want to adopt it. For the folks outside, there are some additional seats in here. If you want to come in and take a seat, please feel free. And CNCF is part of the Linux Foundation, which is far more than just Linux today. Our sister organization, Let's Encrypt, gives out more than half of the world's certificates to secure web pages. LF Networking represents more than 2/3 of the world's cellular population. Automotive-grade Linux is built into all new Toyotas. Hyperledger on blockchain is a huge movement, and then Node.js is one of the most popular application frameworks. We are going to have our event in 10 days in Seattle, and I know that several of you will be there. For those who haven't bought the tickets yet, it's too late. We've sold out. We were there 2 years ago in Seattle and had 1,000 people, and we're going to be back with 8,000 people. That is really just a sign of the level of engagement. Yeah, thank you. It really has been just an incredible journey. We also just had our first event in China a couple weeks ago. I know JJ and some others were there. That we had 2,500 attendees, and it is really a symbol of how global the cloud native community is. We have 3 of our 30 projects actually originated in China and contributed back. And then projects like Kubernetes are used by one of the largest retailers in China, JD.com, that has 25,000 servers. The biggest cluster is more than 5,000 servers. And then we are going to be in Barcelona in May, and would love to have you come over for that. Back in China again, in Shanghai in June, and then San Diego in a year. Okay, so why do we have these ice sculptures here? What does cloud native matter here? I'm going to give my very brief history of the cloud and then show off this metaphor. And folks, there are more seats inside if you want to come on in. So I was a venture capitalist 20 years ago, and companies would come to me and say, I need $5 million to buy a bunch of servers from Sun. There were no apps yet, but they'd say for the website. And Sun was a very profitable, successful company at the time. The application building block was a physical server. VMware came along and said, we can create a virtual machine, we can put a bunch of VMs on the same server, and the application building block changed. Now, interestingly, for each of these examples I'm going to give, Sun, of course, was not the first hardware company. Arguably, IBM invented virtualization in the 1960s, but these are really the companies that popularized it, became the most successful. VMware's a $50 billion company today. Then we're here, many of us have also gone to that other minor conference on the other side of town. Amazon Web Services did not start infrastructure as a service, but they popularized it. They went from needing to buy your hardware and treating it as CapEx to being able to rent it, treating it as OpEx. But interestingly, the architectural building block stayed the same. It was an AMI, Amazon Machine Image, but it was still a virtual machine. And then Heroku came around in 2009. And for many of us who had that experience the first time, they developed this thing, the 12th factor application, and that magic of being able to type git push Heroku, and a minute or two later seeing the new version of your app live, instead of it saying taking weeks or months to deploy, was really just magic. This was the introduction for DevOps for a lot of folks. Now, what's interesting on this history is those first four companies were all proprietary. Heroku was later bought by Salesforce. The next four are all open source. So OpenStack came along and popularized and created an open source version of VMware and AWS. Took a little longer than maybe they expected. There's a hilarious Packet post that I do, blog post that I recommend of how we failed at OpenStack. But for some other people, it's kind of worked fine. Then Cloud Foundry came in 2011 and really took that Heroku kind of functionality and made it available on your own servers or on public cloud or anywhere else. They open sourced it in 2014, and that's actually part of the Linux Foundation. It's a sister organization of CNCF. And then Docker came along and really shook things up in 2013 in popularizing the concept of containers. Now, what's fascinating is that C Groups was developed by Google internally and contributed upstream into the Linux kernel. The Union file system originally came out of IBM and the University of Stony Brook, LXC from another source. But Solomon Hite's genius was to take these three disparate technologies and create a really friendly user interface around it to what I would argue is the fastest uptake of a developer tool ever. And it's the old problem that you hire a new developer on your team and you give her the instructions on how to configure her machine and get your dev environment working. And halfway through, she hits some random error. So she goes to the experienced dev with the long beard and says, oh, I got this error. And he says, yeah, it works for me. And so that really sucks. Instead, you can have all of that encapsulated in a Docker container and she can exactly replicate a working environment. And once you do that and have that experience in dev, it becomes really natural to say, oh, it'd be great if I could use that in test as well. Or if it's working in test, boy, why couldn't we have that work in production? And that brings us to the final step of cloud native and Kubernetes, which we define here as having three main parts, that you divide your application up into microservices, you package each part in its own container, and then you use an orchestration platform to organize that. So if we look back on that history, our core building block went from servers to virtual machines. Heroku and Cloud Foundry used build packs to containers. That was from heavier to lighter weight, both in spin-up time and size. The immutability is a core concept from pets to cattle. And the provider went from a closed source single provider to open source cross-vendor. And when you look at the customer benefits, you get this avoid lock-in. So the open source software stack means you can deploy to any public, private, or hybrid cloud. I want to give a shout out to these pirates. because the amount of effort to get those containers and those shit hooks is really impressive. But this is my metaphor for microservices to say that you have these different parts of your app that can all communicate. You explicitly describe how they talk to each other. Here's our slide for orchestration, that it can dynamically manage and schedule your microservices. And you get an amazing level of resiliency. You can have individual containers fail, machines, even whole data centers, and you can work around that. So this cloud native enables higher performance development and higher performance companies. They have hundreds of times more frequent deployments, far shorter lead time, much lower failure rates, and when they do have failures, they recover much faster. So as a takeaway, cloud-native application architectures are the default choice for greenfield applications. And the leading choice for cloud-native orchestration is Kubernetes. But that brings us to this quote from John Maynard Keynes, that in the long run, we're all dead, that it's too easy, too useless a task if all you can say is that when the storm is past, as we had a few hours ago here, the ocean will be flat again. So I just like this phrase, too easy, too useless a task, because the real world consists of brownfield applications. The total global economy is $100 trillion, and essentially all of that flows through brownfield applications that are generally monoliths. I give this talk to millennials all the time. They have no idea what this is. But it's a great movie that younger people here really should go watch. It's called 2001. You know, this monolith, and it brought technology to Earth. But it's not that kind of monolith. The idea is that you have these bigger applications, often Java, sometimes COBOL, and other kinds of things. And then the natural question, oh, well, I'll just rewrite it. And this is actually a 49-year-old book that explains that that doesn't work. It invented the concept of second system syndrome that shows that as your first system is evolving so much that it's extremely hard to even get your second system to catch up again. Okay, so we have this monolith that our business is dependent on. We can't rewrite it. Monoliths are the antithesis of cloud native, and we finally come to our metaphor here. They're inflexible, they're tightly coupled, they're brittle. What is the solution? Step one is to stop digging, to not just keep doing development the same old way of trying to have this large team that's all working on the same code base, that's doing, in many cases, quarterly deploys because of this long QA cycle. And then step two, and this is my favorite image, is to lift and shift your monolith. And this is the concept that containerizing there's this image that containers should be these felt things that are, oh, I've got my container down to only 50 kilobytes, and I use these multi-stage build to remove all the extraneous stuff. And that's great, that's absolutely the aspiration. But you can take your 8 gigabyte Java application and wrap a container around it, and you've actually created some real value if you can take your CI/CD system and automatically redeploy that monolith in a reliable way. And the lift and shift metaphor, of course, is that you can also take it out of your own data center and into a public cloud like Packet or AWS or one of the many others. And then step 3, and this brings us to Marco, is to start chipping away at your monolith. Yes, so this again is an overly literal metaphor here, but it is a really important one, which is that instead of continuing to do development the way you always have, when you have a new piece of functionality, you can actually write it as a separate application, even in a separate programming language with a separate team that can communicate back to your monolith. This is sometimes known as a strangler pattern, if you're familiar with the vines that grow around the tree, and then eventually the tree inside can die, and the vines still stay in that existing shape. So a nice example of this is KeyBank in North Carolina, where they had an existing monolithic Java application. It wasn't able to support the mobile apps that they wanted to develop, so they wrote a Node.js front end that communicated back to the Java app that was able to support OAuth, and it was Go for performance-sensitive tasks, and had a lot of other functionality built into it. Here, the point is that sometimes just chipping away at the monolith isn't enough. You may actually need a chainsaw to cut out some big pieces of it. Yes, as we saw earlier, but there's a little concern with the number of people in here. Not go too wild on it. And then one of the key thoughts in this process is you want to start with stateless services. This is where you get the highest value. And the example here is the Wikimedia Foundation with Wikipedia, where they have their MediaWiki servers or PHP applications running on Kubernetes today that can auto-scale up to meet demand. And they get a ton of the initial benefits around resiliency, auto-scaling, load balancing. Later on, you want to come back and transition your data stores. And our example here is GitHub, where they've been able to successfully move all of their front-end web servers and their Git processes and such are running in Kubernetes today. They're now beginning the much more difficult task of how to have their MySQL and their permanent storage and stuff move into that cluster as well. And as you're going through those processes, the other CNCF-hosted projects are often able to help with it. So a couple I'll mention here. Helm is a way of packaging up your application to make it reliably deployable. Rook is a distributed storage mechanism that sits on top of Ceph and other storage. Envoy is our third project to graduate that can be used as a service proxy and as the base for service mesh. And there's a number of others that you can learn about. So if you keep going, like Marco here has with this, these gorgeous statues, eventually you will hopefully succeed in evolving your monolith into a beautiful ice sculpture microservice, or most likely a collection of microservices, which is what you are aspiring to. So when we went back before and talked about Kubernetes and greenfield applications, I would say to avoid the soft bigotry of low expectations, of thinking that you have to do a greenfield rewrite to get the benefits of cloud native, that Kubernetes loves brownfield applications. And I will just mention here, actually I didn't mention the Ticketmaster example before, but it's one of my favorites. They have a 40-year-old COBOL application running in an emulator in a container on AWS. And it really is an amazing story of that evolution, and then they've been able to put up a number of other pieces around it. And this whole presentation is available to you at github.com/CNCF/presentations. Along with all the other CNCF material is usable under the CC BY license. And so if you're not able to have Marco come to your corporate event or your enterprise or such, maybe you can at least use the ice sculpting pictures to tell a similar story. So thank you all so much for your attention and for having me.